Okay, I hope I'm audible to all students who are attending this practice lecture for Intermediate Microeconomics Part 1. In this particular lecture, we continue with our discussion of the back problems from Chapter 2 of the book A Short Course in Intermediate Microeconomics by Serrano and Feldman. That's the name of the book. A Short Course in Intermediate Microeconomics by Serrano and Feldman. So if students can recall that in my previous practice lecture, we were discussing some of the problems where we had looked at problem 1 in depth in the previous lecture. Now in this particular lecture, I intend to look at problem 2 and problem 3. Okay, so let's start today's lecture with discussing problem 2 and problem 3. Okay, so let us see what we are given in problem 2. We are given the utility function, which is Cobb-Douglas. It's a Cobb-Douglas utility function. Students can see x1 times x2. The question asks us to graph the utility curves for indifference curves for utility levels 1 and 2. That means if I fix the utility level at 1 and 2, I need to plot the indifference curves. Okay, for this, so let's quickly come to the whiteboard and let's solve this particular problem. So I hope all students can now see my whiteboard. I am just writing the main heading for completeness. We are looking at the worked out problems from chapter 2 of Serrano and Feldman. Okay, so problem 1 was covered in the previous lecture, practice lecture. Let's look at problem 2. We are given the utility function u as a function of x1, x2 as x1 times x2. Okay, part 1 asks us to graph the indifference curves for utility levels 1 and 2. So for utility level equal to 1, I have x1 into x2 equal to 1 because my unity function is x1, x2. So x1 into x2 is equal to 1. Now, how can I plot it? I can take points. Okay, so I can say that when x1 is 1, x2 is also 1. When x1 is 0.5, x2 is 2. When x2 is 0.5, x1 is 2. Okay, so now I can plot this particular curve. Let's look at the graph. On the horizontal axis, we have x1. On the vertical axis, we have x2. Okay, let's take points. So suppose this is 0, this is 1, this is 2. Similarly, 1 and 2. So 1, 1. Then x is 0.5, x1 is 0.5, x2 is 2. And then x1 is 2 and x2 is 0.5. If I join them, I get the indifference curve. This is my indifference curve for a utility level exactly equal to 1. Okay, so I'm writing the points here 1, 1, 2, 0.5 and 0.5, 2. Similarly, let's plot the indifference curve for a utility level equal to 2. So for utility level equal to 2, I have x1 times x2 is equal to 2. When x1 is 1, x2 is 2. When x2 is 1, x1 is 2. Okay, and then when x1 is 0.5, x2 is 4. And when x2 is 0.5, x1 is 4. Okay, so let's plot this now. So let's look at the graph. Again, on the horizontal axis, x1. On the vertical axis, x2. Okay. And we have 1, 2, 3, 4. 1, 2, 3, 4. Let's plot. When x1 is 1, x2 is 2. When x1 is 2, x2 is 1. Then x1 is 0.5 and then 4. And then 4 and 0.5. So if I join all these dots, I get the indifference curve for a utility level of 2. This is 1, 2. This is 2, 1. This is 0.5, 4. And this particular point is 4, 0.5. So we have plotted the utility curves for utility equal to 1 and for utility level equal to 2. This was part A to this particular question. What is part B asking us? Graph the locus. If I come back to the back problems, so we are done with part A. Part B. Graph the locus of points for which MRS of good 2 for MRS for good 1 is equal to 1 and the locus of points for which MRS is equal to 2. So now I need to look at all those points at which MRS equals 1 and all those points at which MRS equals 2 for this particular utility function. So let's first of all find the MRS. Okay. So if I come back to the whiteboard, so I'm first of all erasing all this off for question 2, part B. We are given that the utility function I'm writing again for completeness. This is x1 times x2. Okay. And now let's quickly work out the MRS. How do I find MRS? In absolute terms, my MRS is nothing but mu1 by mu. mu1 is del u by del x1, partial derivative of the utility function with respect to x1. mu2 is the partial derivative of the utility function with respect to x2. What is del u by del x1? If I partially differentiate the utility function with respect to x1, I get x2. If I partially differentiate the utility function with respect to x2, I get x1. So my absolute value of the MRS is x2 by x1. Now we need to graph the locus of points for which MRS, if my mod of MRS is equal to 1, it implies x2 by x1 is equal to 1, which implies x2 is equal to x1. So I can say this is a locus of all the points lying on 45-degree line through the origin. How do I plot x2 equal to x1? The graph looks like this. The graph looks like this. On the horizontal axis, x1. On the vertical axis, x2. x2 equal to x1 is exactly a 45-degree line passing through the origin. You can take points also. When x1 is 0, x2 is 0. When x1 is 1, x2 is 1. When x1 is 2, x2 is 2, and so on. When you plot, you get a 45-degree line. This is my line for x1 exactly equal to x2. So I can write here x1 equal to x2. Okay. So I hope students have understood this. And then if I take mod of MRS equal to 2 as given in the question, then in that case, x2 by x1 will be equal to 2, which implies x2 will be equal to 2x1. Again, take values. When x1 is 0, x2 is 0. When x1 is 1, x2 is 2. When x1 is 2, x2 is 4, and so on. When you plot this, for which I am using a red color now, I am using red color for this. When you plot this, it's going to be steeper. You can check it. This is the ray which denotes x1 equal to 2x2. So MRS equal to 1 corresponds to the black line, x1 equal to x2. MRS equal to 2 corresponds to the red line, x1 equal to 2x. Let me correct myself. X2 equal to 2x1. X2 equal to 2x1. This is X2 equal to 2x1. Okay. So I hope that all students attending this lecture have understood question 2 completely. And then let's look at problem number 3. So let me come to the back problems, and let's look at problem number 3. Different students at the world's greatest university have different preferences about economics, and we need to draw the indifference curves associated with each of the following statements. So we are given students who have told their preference. Measure economic goods on the horizontal axis and books with other subjects along the vertical axis. So based on the preferences, we need to graph the indifference curve. So let's quickly start. Let me first come to the whiteboard and let me erase all this off, and let's write question number 3. Within question number 3, part A. So in each of these cases, on the horizontal axis, we have the economics books at the world's greatest university. And it's a hypothetical university, by the way. Students should not waste time in Googling up the world's greatest university. Okay. So books about other subjects on the vertical axis. Let's look at part A. Let's read the preference of the student. I care only about the total amount of knowledge I acquire. It is the same whether it's economics knowledge or knowledge of any other kind. That is, books on the subjects are perfect substitutes for it. We all know how the indifference curves look like for perfect substitutes. Students can check out my lectures on utility. We have discussed the kind of preferences and their indifference curves. So the utility function is going to somewhat look like this. For part A, suppose economic books are x1, books about other subjects are good x2. The utility function, when I only care about knowledge, I don't care whether you give me economics books to read or you give me other books to read. For me, both are perfect substitutes. My utility function looks like this. It's going to be a straight downward sloping line. The MRS, if you check out, is exactly -1. Okay, so the indifference curves are downward sloping parallel lines. I can draw a family of indifference curves. I can draw a family of indifference curves. So the slope is -1. Perfect substitutes. So I can say that therefore the indifference curves are ICs are downward sloping parallel lines with slope equal to -1 and the direction of preference as, which is the direction of preference? Northeast. Because higher indifference curves are in the northeast direction. I'm going in this direction, the northeast direction. Okay, this was part A. Within question number 3, let's look at part B. Again, let me first draw a diagram before reading the question. Economic books, other books. Okay, let's call this as good x1. Let's call this as good x2. Let's come to part B. I hate the Serrano Feldman textbook. Okay. And other economic books. That means the student hates the economics books. On the other hand, I love everything else in the WGU curriculum. WGU is the world's greatest university. That means in part B, the student is telling that she hates economics and all books relating to economics like Serrano Feldman. I hope Serrano and Feldman don't feel bad when they listen to this lecture, if in case they do. Okay, so the student hates economics textbooks but loves other books. So I can say that for part B, For this particular student, economic books is a bad and other books is a good. So recall from my lectures on preferences and utility, when you measure the bad on the horizontal axis and good on the vertical axis, your indifference curves are upward sloping convex. And your direction of preference is now northwest. Because you always want to reduce the bad and you want to increase the good. Northwest is my direction of preference. So higher indifference curves are increasing in the northwest direction. So I can say, therefore, the indifference curves are upward sloping with the direction of preference, being northwest. Okay, this is part B. Let's erase all this off and let's now look at part C. Question 3, part C. Let me first draw the basic diagram. Again, on the horizontal axis, I have economic books, which is good X1. And on the vertical axis, I have other books in the WGU curriculum, which is good X2. Let's come back to the back problems and let's read part C. I really like books about economics because I want to understand the economic world. Books about other subjects make no difference to me. Now, this is basically Akshay sir. That's me. I really love to read economic books, but then I don't care much about other books. For someone who loves only economics, likes only economics books in order to grasp economic knowledge. So the other books are not of much relevance. That means I can say that the other books are neutral to me. Whether you give those books to me or you don't give them, I am equally happy. The question is not saying that I hate other books. Books about other subjects make no difference to me means whether someone gives me other books or doesn't give, I'm equally happy. The other books are neutral books for me. So I can say that economic books are a good, but other books are a neutral for me. And recall from my lectures on utility, how do I plot the indifference curves when neutrals are measured on the vertical axis? The indifference curves are vertical. And the family of indifference curves are increasing in the east direction. They are increasing in the east direction. So I can say, therefore, the indifference curves are vertical and the direction of preference is east. Is east, or you can also say right. You are moving to the right. Higher indifference curves are increasing in the right direction. Okay, hoping students have understood this. And then let's look at the last part of this particular problem. Again, let me first draw the basic axis. On the horizontal axis, we have economic books. On the vertical axis, we have other books. Let's come back to the back problems. I like all my courses and liberal education that WGU offers. That is, I prefer to read books on a variety of different subjects rather than to read lots on one subject and little on the others. Now, D would be an ideal student. Ideal student means this student likes to read some amounts of every book rather than the extremes. So part D represents an all-rounder, basically. All-rounder student. She likes to read economics, she likes to read liberal arts, she likes to read other subjects. So instead of being at the extremes, this student would want to be at the average. What kind of preference? So instead of being at the extremes, so this is one extreme, call it as point A, where the student is reading very less economic books but too much of other books. This is another extreme, which is where you love economics too much as compared to other books. The student does not want to be at these extremes. The student wants to be somewhere in the average. That means for this student, C is preferred over A and C is preferred over B also. Because she does not like to be at the extremes in terms of reading books. She wants to be average in terms of reading every topic. That means I can say that if A and B lie on a same indifference curve, then C should lie on a higher indifference curve. Cobb-Douglas, convex indifference curve, C. Both A and B, suppose hypothetically, lie on the same indifference curve. Since consumer prefers average, C is like an average bundle. The average bundle lies on a higher indifference curve. I can join points A and B. You can see that it passes through C. So C is like the average of A and B. Not exactly, it may be an average. So C is like an average of A and B, and C lies on a higher indifference curve I1, because clearly in the question it was given that the student does not like extremes. The student likes the average. If you guess the question, it's clearly saying that the student does not like the extremes. That means the student does not like to be at B and A because these are the extremes. The student prefers to be on the average, and the average should lie on the higher indifference curve. So my indifference curves are downward sloping convex. So I can say that therefore indifference curves are downward sloping and convex to the origin. They are downward sloping and convex to the origin, and the direction of preferences, higher indifference curves are increasing in which direction, guys? This is I2. The direction of preference is northeast. Higher indifference curves are increasing in the northeast direction. Okay, so I stop in this particular practice lecture. The objective of this practice lecture was again to discuss a few more back problems. We have done 2 back problems in this lecture. In the next lecture, I'm going to start the discussion from problem number 4. And hopefully in the next lecture, we will be done with our back problems for chapter 2 of Serrano and Feldman. So I stop in this lecture. I hope all students have enjoyed this lecture. Any doubts, you can unmute your mics and ask in this live lecture, or you can drop a WhatsApp text or call me for doubts, or you can mail your doubts at divineschoolofeconomics@gmail.com. This is where I stop in this lecture.